Welcome to this session. This session, we are going to give more examples on application of quotient tool. So the first problem is an appetizer. Find dy dx given that y is x over x minus 2. So solution for this. We let u to be x and v to be the denominator x minus 2. So this implies u prime is 1, and this implies v prime is also 1. So dy dx is u prime v minus v prime u divided by v squared, which will be 1 into x minus 2 minus 1 into x divided by x minus 2 square. Now you simplify this expression. So dy dx will be x minus 2 minus x over x minus 2 squared, which is minus 2 over x minus 2 power 2. Or you can say dy dx, these are simple expression to expand, minus 2 over x squared minus 4x plus 4. So this is the solution. Problem 2 or B. Find dy dx. Find dy dx given y is a function x plus 4 over x squared plus x plus 1. So this is the next problem. It's also still an appetizer. So we let numerator to be u, denominator to be v. So which means that u prime is given by 1. Then this means v prime is 2x plus 1. So by definition, dy dx is u prime v minus v prime u divided by v squared. So will be 1 into x squared plus x plus 1 minus 2x plus 1 multiplied by u, which is x plus 4, divided by the square of v. So x squared plus x plus 1 and then squared. So next step, we simplify the numerator. So dy dx will be x squared plus x plus 1 minus 2x squared plus 8x plus x plus 4 divided by the square of the denominator, square of x squared plus x plus 1. Now we simplify further. Dy dx. So x squared plus x plus 1 minus 2x squared minus 8x minus x minus 4, x squared plus x plus 1 and then square. So you see, in this case, x and minus x cancels out, so that we have dy dx x squared minus 2x squared is minus x squared, and then minus 8x, and then 1 minus 4 is minus 3, x squared plus x plus 1, and then square. They have minus x squared minus 8x minus 3 over the square of this. Problem C, find g prime of t and g prime when t is minus 2, given that g of t is a function t squared plus 1, t squared minus 1. So there are two parts. First, we find the derivative. Second is now to evaluate the derivative at -2. So solution, let u to be t squared plus 1 and v to be t squared minus 1. So this means that u prime is 2t, and this means v prime is still 2t. Now, by definition, g prime of t, or dg dt, is the same as u prime v minus v prime u divided by v squared, which will be u prime is 2t into v t squared minus 1 minus v prime is 2t into u t squared plus 1 divided by t squared minus 1 square. So g prime of t, open this, so we'll have 2t power 3 minus 2t minus 2t power 3 minus 2t over t squared minus 1 power 2. Now this will simplify 2. So we'll have now ahead g of t so g of t given by t squared plus t plus 1 over t squared minus 1. So we say this is u, this is v. So u prime is 2t, v prime is 2t. So g prime of t will give you u prime v minus v prime u divided by v squared, which will be 2t into v is t squared minus 1 minus u, v prime is 2t, u is t squared plus 1 divided by t squared minus 1 squared. So g prime of t is 2t power 3 minus 2t minus 2t power 3 minus 2t divided by the square of t squared minus 1. Now you see this and this cancels out, so that we have g prime of t is minus 4t over t squared minus 1 power 2. But you evaluate g prime at minus 2. So this will be minus 4 into minus 2 over minus 2 squared minus 1, then square. So this will be 8 over 4 minus 1 square, and 4 minus 1 is 3, so it will be 8 over 3 squared, so which will be 8 over 9. So that's how we solve that problem. And then D, given that W is Z squared over square root of Z plus Z, find W prime of Z and W prime at 9. So solution, we let U to be Z squared and V to be square root of Z plus Z. So this means that U prime is 2Z, and this means V prime, this is the same as Z power half plus Z. So we'll have a half Z power negative a half plus 1. So W prime of Z will be given by U prime V minus V prime U divided by V squared, which will be 2Z into root Z plus Z minus a half Z is power minus a half plus 1 multiplied by U, which is Z squared over square root of Z plus Z squared. Now we simplify this one as, so Z times this one will give us 2 a half plus 1. Remember this power is 1, square root is like a half, so a half plus 1 is 3 over 2 plus twice 1 plus 1 z power 2 minus a half, and then 2 plus minus a half is 3 over 2, and then minus z power 2 divided by square root of z plus z raised power 2. So this implies that w prime of z, now this and this will give us now 3 over 2 z raised power 3 over 2 plus, now this will be z squared divided by square root of z plus z raised power 2. So that's what we have. And z prime at 9 will be 3 over 2, 9 raised power 3 over 2 plus 9 squared divided by square root of 9 plus 9 squared, which will be, so 3 over 2 times 9 raised power 1.5 plus 9 squared, that is 243 over 2 divided by square root of 9 plus 9, and then square, it's 144. So 243 divided by 2, divide answer, we get 27 over 32. And then next problem, that is 1, 2, 3, 4, 5e. G is given by 1 over 1 plus e raised power x. Then g prime of x is equals to so let u to be 1, v to be 1 plus e raised power x. So this means u prime is 0, v prime is e raised power x. So g prime of x will be u prime v minus v prime u divided by v squared, which is 0 times 1 plus e raised power x minus e raised power x times u, which is 1, divided by 1 plus e raised power x squared. And then this will be g prime of x will be equals to, this will be 0, so we'll have negative e raised power x, and then divided by 1 plus e raised power x squared. And lastly, given that f of x is e raised power x over x squared plus 1, find f prime of x. So solution is still application of quotient rule. So let u to be the numerator, v to be the denominator. So by that, then that tells us that u prime is e raised power x and v prime is 2x, not 2 power. So f prime of x, or the f dx is u prime v minus v prime u divided by v squared, which will be e power x into v x squared plus 1 minus v prime 2x into u e raised power x divided by x squared plus 1 squared. So when you simplify this, you get f prime of x equals to x squared e power x plus e power x minus 2x e power x divided by x squared plus 1 squared. Now, numerator can be factorized. So you can say x squared minus 2x plus 1 e raised power x and then divided by x squared plus 1 squared. But you see this quadratic part here, product is 1, sum is minus 2. So numbers, -1, -1. So we have x squared minus x plus 1. So pairing, so this is x into x minus 1 into x minus 1. So x minus 1, or simply x minus 1 squared. So we can say the derivative of the function is simply x minus 1 squared e raised power x squared plus 1 squared. So that's how we find the derivative of that function and the rest of the functions. Thank you.